Good day. We are Group 5, consisting of Tessa Beduyas, Carl Comigan, Kaiser Ramos, Charles Romanda, and Ken Tapotabo. Today we are going to learn about cosine, sum, and difference identities.
This happens when we encounter a cosine with two standard angles being added or subtracted. An example of this would be cosine 60 degrees plus 45 degrees or cosine 60 degrees minus 30 degrees.
We could also use this when we don't directly see a plus or minus symbol, just a single term. An example would be cosine 105 degrees, which could be expanded to cosine 60 degrees plus 45 degrees.
Another use for this is when simplifying problems that only involves theta as the variable, and not numbers like 30 degrees or 60 degrees, and incorporates cosine sum and difference identities, as well as other fundamental trigonometric identities.
The formula for this would be cosine A plus minus B is equals to cosine A times cosine B plus minus sin A times sin B. This simply means that cosine A plus minus B could be solved by adding the products of cosine A and cosine B and sin A and sin B. These formulas come from the properties of the unit circle and the relationship between sin and cosine. The operation it starts with will also be inverted or become opposite.
Let's first start off with cosine 105 degrees, which could be expanded to cosine 60 degrees plus 45 degrees. Then it becomes cosine 60 degrees and cosine 45 degrees, minus sine 60 degrees and sine 45 degrees. We now need to substitute these standard triangles or known values.
It will now become 1 over 2 times square root 3 over 2 plus square root 3 over 2 times 1 over 2, which will then become square root 3 over 4 plus square root 3 over 4.
Combined, it will become square root 2 minus 6 all over 4, which is our final answer.
Another example would be 60 degrees minus 30 degrees, and we would substitute known values again.
It will now become 1/2 times square root of 2 over 2 minus square root of 3 over 2 times square root of 2 over 2, which will then become square root of 2 over 4 minus square root of 6 over 4.
Combined, it will become square root 3 over 2, which is our final answer.
We will then talk about simplifying a problem that only involves theta as the variable and incorporates cosine sum and different identities, as well as other fundamental trigonometric identities.
Our problem would be to simplify cosine theta plus cosine theta minus 2 cosine squared theta. It contains the cosine sum and difference identities, and the Pythagorean identity that would be established later on.
The cos theta plus theta part will become cos theta times cos theta minus sin theta, which will then become cos squared theta minus sin squared theta, whereas the cos theta minus theta would become cos squared theta plus sin squared theta instead.
According to the Pythagorean theorem, cosine squared theta plus sin squared theta becomes 1. So everything becomes cosine squared theta minus sin squared theta plus 1 minus 2 cosine squared theta.
Combining negative 2 cosine squared theta with cosine squared theta, it will become negative cosine squared theta plus sine squared theta plus 1.
Applying the Pythagorean identity again, it will become negative 1 plus 1, and our final answer would be 0.
That is all for today's lesson. We hope you learned something new today. Thank you for watching.